Okay, first thing, you get a point for finding these intersection points. Now those are the x-coordinates. I don't know why they call them S and T, but they do. You can call them A and B. Okay, so you got 1 point right there. Yes. That's fine. You either are going to put them here or you're going to put them here. Just that you have it there. That's all. Okay? Question? We'll do the problem. What parts we need. Then you get a point for this integrand. If you don't put the x down, not a problem. It is a problem for me, but not a problem. And then 1 point for the answer to 3 places. The question is, what if you do more? I don't recommend it. Don't do more than what you're asked for because we read it. And if it's mathematically wrong, we take points back. You have to have at least 3. Or an exact answer. Yes?
Why is it L of x plus 3 like x?
Well, we're going to do that. We're going to correct it first. Now, there's 2 points for the integrand, and then 1 point for using this with your answer. I'm not sure if they'll give you the answer point. So it depends if you want to be harsh on yourself or kind to yourself about the points. So if you have this with an answer that's correct for what you put into your calculator, you can get a point, and you get a point for getting this integrand in the right order, but for getting the 3, or you get a point for having this with the 3 in it, but in the wrong order. You'll have to take a point away. So we'll give you 1 point for this, 1 point for that, 2 points. 1 point for either using the correct functions in the wrong order or not using the correct functions but in the right order. Sounds weird. So you could get, I think you're only going to get the 1, but I'm not sure. Because I haven't graded one of these. There was another question, though, that I didn't answer. Yes? I'll be doing the problem, so you see why. Because we're rotating it. Yeah. Okay, well, and I'll go over that. Right now, you're just grading it. Now, on the last part, you get, now, you guys, if you read your y coordinates off, guys, Declan, if you read your y coordinates off your graph, that's fine, because those are the y coordinates. We will see why they wrote it that way, but that's just for the graders. You don't have to worry about that. You just copy the y values down. And then you get 1 point for having these 2 functions subtracted. You will get nothing for this. That's 0 out of 2. Okay, because that's wrong. So you'll get nothing for that. And then you'll get a point for having these, r squared minus little r squared. If you have them in the wrong order, you lose a point. You get 1 out of 2. Did everybody get their points? No. Those are the y coordinates. Don't worry about that. It's t minus 2. If you take the t value and subtract 2, you will have the y value. So if you write them off your calculator, which is ridiculous that they wrote it this way. Let's go back and look at this. If I do this t minus 2, which is kind of odd. I don't know if it's coincidental that that's pretty darn close to pi. I thought that was kind of odd. But anyway, this second y value is 1.14619. So that's the upper limit. And then, does anybody know what 0.15859 is? What did you guys get for that? It's negative 1.841. What else? Oh, that's good. Well, you really should have all of these. Because when you do the calculation, you have it. So if you have these numbers, you are right. We'll talk about why they did s minus 2, but in a second. Okay. Anybody get 4 points? Well, just the score. Anybody have a 4? 5? How about 5? No 5s?
I have 6.
What? How about 6? 6?
6.
Great. 7? 8? Do we have any 9s? Oh, you guys. We had 2 9s in the last class. Okay. Maybe. Okay. Do we have questions on part A? Are we okay with A? Okay, bear with me. I have to draw a picture. We have questions on B. I'm aware of that. Now, we are going to rotate around y equals negative 3.
That made no sense.
You guys, you got to do the geometry. Is that straight? No. I know. I see that. Well, we're going to do it. Okay?
Here we are.
I don't know. Okay, red, dotted. Okay. I don't know why that's there, but I'm not going to worry about it. Now, it's unfortunate you don't get to use iPads and smartboard software, but that's the way it is. Okay, I'm going to copy that. I made it really big. I don't like that. And then I'm going to flip it. No, flip. Okay. And it doesn't really matter if you know what that solid looks like. It's rotating around that line, which is, what's that line? Y equals negative 3. So first thing you got to do is have a good picture. Okay, Alex? Stephen? So we're going to take this figure and rotate it 360 degrees around it. Okay, can you kind of see the volume, the shape there? Now this ends up giving me, if I slice it this way, a circle. I can bring an apple in and take the core out. This is like a bowl, but unfortunately, there's a hole in the bottom. So let me try and draw that three-dimensionally, which I made it so big it's going to be tricky. But it's okay. So which is it going to be, dx or dy?
dy. No dx.
Let me make this thicker now. So if I pull it out, it looks like this. No, I'll try that again. I'm not used to drawing these on the side. Okay, there's my washer. Remember, do you guys get this? This is coming out at you. I need that 3D pen. It's coming out around like this. So this is flat. My little model here is flat until this starts rotating. How many degrees is it going to rotate? 360. It's going to go all the way across. Now you can sort of see this coming out at you. So that's my washer. And you don't even have to draw it three-dimensional. I do that to kind of help you. There are some great pictures in your book. And there are great things. If you Google this online, you'll find some other pictures. We also have this software, but I don't believe it's on the computers yet in the lab. It's called AP Calculus CD. They're not making it anymore. I don't know why, but they're not. Okay, it's a great software piece. You need to be paying attention to. And I'll try to get in here, but they have some explorations. But they have these pictures, and they show the rotation. So if you're having problems visualizing that I really recommend that. Okay, so how do I find the volume of this washer? It's pi, what? Big R squared. I'm going to take the big cylinder minus the little cylinder. In this case, is it delta x or delta y? Delta x. And I'm here tomorrow morning. I'm here after school tonight if you need some extra help. So that's what I have to do. Notice it's not r minus little r, quantity squared. So make sure you get that right. Now I have to find the radius. Kind of putting that off, wasn't I? So shall we find the little radius first?
Yes.
Okay, so the little radius goes from the axis of rotation to this point right there. Now I've got an issue here. personally got an issue. I don't quite know how to write that because this is a negative number and I got that radius. So let's go and redraw the radius further out where my function's actually positive because it's easier for me to see. So now, how would you find this total length? What's this length right here? How big is that? Not negative 3, it's 3. If I come over here and do it, that hasn't changed. That length is still 3. So little r is going to be 3 plus, well, we're going to check this one out. What about that one? But it's 3 plus, how do you get the full radius? What do you have to do? Add in the y coordinate there, right? So we call that one y1. I don't care what you call what. So it's 3 plus y1. Let's check. Why does it work? Because it does over here. Because this distance is 3. What's true about this y coordinate? It's negative. So if you take 3 and you add that negative number, I'll still have a positive number, right? Because 3 is bigger than that. And I'll have that distance right there. This is geometry. Not one bit of calculus here. The calculus is when I throw the integral in there, which is the easy part. It's always the easy part. Okay, do you see that? That you got that? Why it's 3 plus the y coordinate here? Because this y coordinate is negative. So, this is 3 and this is 1. The radius is going to be 2. Now, let's do the next one. Oh, we'll do that in a second. So, let's see. Let's try that color. Now, I want this radius. Now, let's go to where the y value is positive because that's easier. I don't know why my computer's doing that. Oh, wait. Shoot. Hopefully, we can still see it. Now, how big is this distance? 3. And then we have to add in what? Yeah. That's why it's plus 3. If I could get this out of here. Let's try escape. No. I'm sorry, I don't know why it's doing that. Okay, so I've got this distance. Why is it plus 3? Because the distance from the axis of rotation, because it's this curve, is 3 units, and then we're going to add in the y coordinate from the curvy part. That was y2. I could call it y1, call the other one y2. It doesn't matter. Because I want the biggest radius. So I'm going to go from here up to the top. Maybe if I do this. Okay, this is like crazy. New idea. Okay, so there we go. The volume is equal to pi integrate. The big radius is 3 plus y2 squared minus 3 plus y1. And it's dx. Hey guys, you notice that it's easier to see the radius when I write it like this than when I have the functions in there? Like when you said, why did you add the 3? Here I can see the 3 much more clearly. And by the way, where do you integrate from on the x's? Because we're going to be with the x's here. From this x coordinate to this one. They called that one S. They called this one T. You can call it A or B. You can just write them down. It doesn't matter. Now, if I clearly have y1 and y2 defined over here, what they are, that would work. But let's go ahead and put the functions in so it looks better. So it's pi S to T, and it's 3 plus, now which one's y2? Oh, that was the curvy one. That was the log function. The words in math, right? 3, and this is the line, x minus 2. Now, somebody in the other class said, and if I don't write dx, I'm not in trouble. Which really you are, because that tells you what variable you want in there. Could I simplify that? But I really don't want to. I want my points. Now, do you understand how to add this into the calculator? Okay, so I heard somebody say they didn't get that. Okay, I got to draw my picture again. Because guess what we're going to do now? we're going to rotate around the y-axis. Now notice that when I rotated around a line other than the axis, I added or subtracted that number. I have to look at the geometry to figure that out. I don't have it memorized. I have to draw the picture. This one is rotating around the axis, so this is going to be simpler. It's not going to have a 3 plus or 3 minus or anything. I'm just going to rotate it. Now, have you guys been in the art class and made the ceramics? You know, I probably was a great thing that I did. Mine didn't work out very well, but I started with a solid, like in a dome, and I put my hands in it and I pushed it out. That's what we're doing. We're making bowls. It'd be kind of cool if you could make bowls that look like these.
Do it. The actors feel like ceramics. We should all make bowls.
That's not a bad idea. Better projects. Okay, I'm going to clone that. Then I'm going to flip it. And then put it over there. In the right place yet? Now, those of you who can't draw 3 dimensions, you know what? It's no big deal. Just draw the radii in. Here's the radius. And here's another radius. That's big R. That's little r. Now, I kind of like to see the picture, so I want to draw the picture. Is that okay? This is like an ice cream cone. Okay, guys, it's a funnel. I was thinking of ice cream myself, but haven't you ever had an ice cream cone where the bottom breaks off and then it drips all over? So this is like an ice cream cone, and it's shaped a little weird, but you pulled that inside out. So there's a hole there. Do you see the hole? I'm just going to do that. Now, I'm so close I can't see that three-dimensionally. That's not too bad. Okay, Stephen? How am I going to do this? Okay, you guys, if you work hard during this hour and you don't do anything outside of class, I still think you're going to get a 3 or better on the exam. So those of you who aren't working hard and are working on other subjects, you need to be doing math in math class. Because who wants to go back and watch the video again? Only if you want to go to sleep, right? Okay. Now, I always like to do this first. What's the thickness? Is it delta x or delta y? Okay. So it's pi, big radius squared minus little radius squared. Okay, now I got to find the radius. What's little r? By the way, we called this one y2, didn't we? And this one y1. I don't want to switch it on us. So what's little r equal to? Okay, Stephen? What's the little radius? It's this. It's not y, it's x. So that's x2. Okay? Max, how do I get the big radius? It's this length. It's that length, which is x1. I didn't rotate it around anything other than the axis. It's really 0 plus x1. And it's 0 plus x2. So we don't write the 0. Okay, ready? You guys are really chatty. So it's pi integrate. Because some of you are going to ask, where's s minus 2 and where's st minus 2? Where did that come from? And it's pi big radius squared, which is y1, minus, oh, sorry, r. Thank you, because I didn't follow my own directions. Big R is x1 squared minus x2 squared. Okay, you guys, dy. And we want what variable in here? We want y's. So you should not have any problem with y equals x minus 2. So what's x equal to? I want x in terms of what? No? Y plus 2. And then we have y equals the natural log of x. Not so bad. Okay, girls? Exponentiate each side. That's e to the y. What's e to the log of x? X. Right. There are only a few properties you have to know. There it is. That's how the exponentials were, how logs were defined. So it's pi x1, which was x1. X1 was the line, right? That's x1. This is x2. So it's y plus 2 squared minus e to the y squared dy. How do you find the y values? You either read them off your graph, and we have s and t. Let's do it this way. This is t and this was s, right? Yes, but I wouldn't simplify it, because if I accidentally simplify it to e to the y squared, I'm wrong. No point in doing it. Not asked to do it, don't do it. Yeah, as long as you clearly say to what they are. Hey, Zach? Okay, how did they get t minus 2? Okay, Alex? It was y equals x minus 2. Okay, so what did they do? They put in this value, and they subtracted 2. You could just read it off your graph. Who cares? We don't care. That's what they did for the graders. You don't worry about it. The graders have all the answers in front of them, and if they don't know something, they ask. So don't worry about that. So if you have the decimals there rather than t minus 2 and s minus 2, that's fine. Why is it minus 2? Because I could have evaluated either y equals the log of x, or I could evaluate in this one. I chose to do that one. Could you have put the log of s and the log of t? Yeah, you could. That's going to be equal to x minus 2. If you don't believe me, put it on your calculator. I don't even believe it. Yes. Those were what they called them. I would call them A and B. These are the x coordinates of where they intersect. Remember? They were these values over here. If you subtract 2 from that, you get the y value. These are the x coordinates. You have to use your graphing calculator. You could just read it off your graph. It's the y's, though. Okay, guys. Now, for tomorrow, this is what you should do. Okay. Okay, guys. That problem should look familiar. And you know that we're going to take problems right off the AP exam. So if you do them, what are your chances of getting at 95%? Pretty high. Expect that, but you got to do the work. And at least if you do the work in class, because tomorrow, if I don't do problems, you can get at least 3 problems done in class, and now you're almost done with them. And we have Monday as well. Okay? Now, you guys, for tomorrow, do C. I want the region S. I wish it had been R, but anyway, it's not. I want this rotated around y equals negative 1. Now, it's not. Guys, if you listen, it's a lot easier. It's not going to be 0 plus. You're going to have to factor in that negative 1. We have not done the last part. The first 2, but not the last part.
We did the last one.
I said I'd give you a bonus for it, but I didn't see it.
You gave us the wrong score on our part. Oh, yeah. We have to ask you.
Yeah, you have to ask me.